if you want to build robots that operate in space, you have to make them very resilient, very adaptive, and to a certain degree autonomous. And I think the problem here is that autonomy that involves a high-level decision-making, and it is something that for space applications you have no options, basically, right? So because of the distances involved, you cannot do remote control. I mean, in the low Earth orbit, you have a delay, communication delay of almost 1/3 or 1/4 of a second. And if you start thinking about robots to Mars or other planets, we're talking about minutes. So there's no option right there. So you need to have a robot that actually will operate autonomously. Again, you cannot send humans. Every time you have humans, the mission becomes much more expensive and it's much higher risk. And space is an unforgiving environment. It's very difficult and dangerous. The only way you have is to have autonomous systems do the job that a human will do. But these days, people are thinking of sending humans to Mars. Even if you send humans, I think the current architecture is that we're not going to send everything at the same time. We're probably going to send the supplies first, and they're going to be land on Mars, and they will be waiting there until the crew arrives. And we don't have the capability of sending everything in one shot. So imagine now you have developed algorithms that they will be some kind of autonomous robotic system vehicle that will send the supplies that will land on the robot and basically deploy and waiting for the crew to come there. So all these capabilities need to be developed, and I think the more reliable and safe we make them, the better it is.